Welcome back to a new machine learning tutorial. In this video we are going to talk about the cross-validation techniques. Let's start coding. I'm in Visual Studio Code interface right now. You can use any code editor that you want. I'm going to be closing the welcome page. I'm going to be opening a new file named crossvalidation.ipynb. And now I want to select my kernel 3.11.4 and we can make this run, and let's talk about cross-validation. So in really simple terms, let's think like we have 10 data points, like this, 8, 9, 10, and let's add values like this. So this is going to be our data, and I need to add spaces like for 2 digits, and in cross-validation, what we do is, after typing them out, I will talk about it. So think that we have 10 data points, and when we are training our model, we do train test split. Let's say we set the test size as 20%, so our training set size is going to be 8 data points. In the scenario, test set size is going to be 2 data points. So let's say that we take this 8 as training and these 2 as test. So in cross-validation, what we do is, in this range, like for the training sets of 8 and testing set of 2, we do like, let's think like we take this 6 and then we take 9 and 10 together, so we don't take this 2 in training. And then what we do is we just take this 2 as testing set and take this as training set. And then we do, let's say like we take this 2 and take others as training set, and we compare the performances. For example, we have a K-fold cross-validation. We are going to talk about that, and this K specifies the amount that we want to divide the data. Like if the K is 5, we are going to have 5 parts in here, like this is going to be, 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 this is going to be different parts, and we are going to apply cross-validation like that. So this is cross-validation in basic terms, and we use it for assessing how well a model generalizes to an independent dataset. So as we talked, it involves splitting the dataset into multiple subsets, training the model on some subsets, and validating it on the remaining subsets. So in the example of K-fold, if the K is 5, then it's going to divide the data in 5 equal parts. So this process is repeated multiple times to reduce the variance of the model performance estimate. Okay, let's code it. When we are coding, you are going to understand better, and each technique requires different code. Also, I will be talking about each technique and how it works when we are talking about them. But we are going to start with dataset creation. So I will say from scikit-learn.datasets import make classification. I'm going to create a classification data with this, and I'm going to import numpy as np. Then I'm going to set my x and y using make classification, and I'm going to set the number of samples as 1000, and I will say number of features is going to be 20. So each sample has 20 features, and number of informative is going to be 15. Out of 20 features, 15 are informative, and number of redundant is going to be 5. The remaining 5 features are redundant, derived from the informative ones. So I'm going to make this run, and we can just check x is like this, and we can check y is like this, and also we can check the shapes like x.shape. We need to have 20 features on 1000 rows, great, and the y shape we are going to have a vector, great. So our matrix and vector is ready right now. So let's apply the basic approach. Train test split firstly. This is the simplest validation technique. So I will say from scikit-learn.model selection import train test split, and I will say, actually let's do it in the new line. I will train logistic regression model, so it's going to be easy to interpret linear model import logistic regression, and we are going to use accuracy score for evaluating the performances, and I'm going to make it run. Now I'm going to use my train test split. Like I'm going to set the test size as 30%, so 300 data is going to be in the x test and y test, 700 are going to be in the X train and Y train. So we can set it like X train, X test, Y train, Y test, and we can use train test split on this, and we can say X, Y, and test size is going to be 0.3. And now I'm going to train my model. By the way, we are also going to compare the performances on the different cross-validation techniques, and also we are going to take the accuracy score on the simple technique, train test split. So let's train a logistic regression model. For that, I will say model is going to be, I'm going to initialize the logistic regression, and then I'm going to train my model using the fit method we have, X train and Y train. And now, after training, we are going to make predictions and evaluate the model. So I will say Y predictions are going to be, we are going to make the predictions with X test we have, and then we are going to get the accuracy, like accuracy score, we will pass the test and predictions. And let's see our accuracy. It's 0.76. Great. So here is the problem. The train test split method has a drawback. The model's performance heavily depends on the random split, which might not be representative of the entire dataset. Okay, now we are going to talk about K-fold cross-validation. And in here, let's talk about its theory and formula. K-fold cross-validation divides dataset into K-equal-sized subsets, which we can also refer as folds, and the model is trained on K-1 folds. For example, if you have 5 data points and your K is 5, then let's say you are going to take this fold on testing, then the remaining data points 4 are going to be used in the training side. And this process repeated K times, with each fold used exactly once as the test set. And for the finding error, like let's say cross-validation error, let's say it on there, cross-validation error, we are going to use a formula like, we are going to divide it with K, and we are going to take that fold's error, like this. This is the error on that fold. Let's use it with capital. Also we can say EE, and in here EE is the error on the ith fold. This is going to be our error formula. So let's do that. We will import K-fold from scikit-learn model selection like this, and then we are going to initialize the K-fold with 5 folds. So I will say K-fold, K-fold, number of splits 5, shuffle true, and now I'm going to go K-fold. We can see our number of splits, and we can call split, and we can give X, actually it's split like this, and this is going to separate our data into 5 equal parts since we initialize it with 5, and we are going to write a for loop using this. So I'm going to create an empty list named accuracies, and I will say for train index and test index in split X, I will say X train, X test, X train index, and X test index. I will say Y train and Y test are going to be Y train index and Y test index. We are going to set model like this. We will say model.fit X train, Y train. Then we are going to do Y prediction is going to be model predict X test, and we will say accuracy is going to be accuracy score. We will give Y test with Y predictions, and we are going to append them into list like accuracies.append accuracy like this, and I'm going to make this run. And what we do in here is we iterate over this data parts, like we splitted our data in 5 parts and we set our train and test for both x and y for every fold. Then we initialize the model, we train the models with that fold in the loop. Then we take predictions and we get accuracies, and we get the accuracy for that fold and add it into our accuracies list. So in the accuracies list we are going to have 5 different accuracies right now, and we can find the mean accuracy. Like mean accuracy is going to be numpy mean accuracies. So our mean accuracy is 0.76, and we got higher accuracies like in here, and we got lower ones compared to the train test split. So K-fold cross-validation gives a more reliable estimate of model performance since the model is tested on different subsets of data. Now we are going to talk about stratified K-fold cross-validation, and this is used for classification tasks to maintain the proportion of classes in each fold. Like I'm going to call the y, not in here, I'm going to code y in a Python shell. We see that we have different ones and zeros, and now in every fold we take, like think like we are going to take this, we are going to take this, we are going to take this. Now in each part the 1 and 0 count is going to be equal, and this is what stratified K-fold cross-validation code. So it ensures that each fold has approximately, maybe it can differ 1 or 2, but only in like you have more zeros than ones on stuff like that. Each fold has approximately the same percentage of samples of each class as the original dataset. Like if your case is you have, let's say you have 500 ones and 500 zeros, then your percentage is 50% for the 1 and 50% for the 0. So in every fold you are going to have 50% zeros and 0% ones. And now think like you have 70% ones, like 70% of ones and 30% of zeros. Now in every fold you pick, you are going to have 70% one, like if your number of splits is going to be 5 again, which means you are going to have 5 folds. In your every fold you are going to have 200 data points, and 140 of them are going to be 1 and 60 of them are going to be 0. If this is your case in y, the target vector, it's completely going to have the same percentage. So how we are going to code that is we are going to say stratified K-fold, and we can clear this cell output. We are going to say stratified K-fold. Firstly we need to import it. I thought we imported it earlier from scikit-learn model selection import stratified K-fold, and now I will say stratified K-fold, like stratified K-fold number of splits is going to be 5, shuffle is going to be true, and we are going to do similar operation like we will say accuracies again, it's going to be an empty list, let's say like this, and then I'm going to say for train index and test index, let's say like for in stratified K-fold.split, and we will use x and y like this. Then I will say y train, y test is going to be y train index and y test index, and I'm going to say x train, x test, x train index, and x test index. We will say model logistic regression, we will say model.fit, and we will say x train, y train. Then we are going to say y predictions are going to be model.predict x test like this. Then we will say accuracy is going to be accuracy score. We will say y test with y predictions, and we will say accuracies stratified K-fold.append accuracy. And now in here I'm going to call accuracies stratified K-fold, and we see that we have values that are not that different, like they are closer in terms of values. And let's call like mean accuracy, it's going to be numpy mean accuracy is stratified K-fold, and I will call mean accuracy, it's 0.75 right now. Okay, this is the logic of the K-fold and stratified K-fold. Now I'm going to show you how you can simplify the cross-validation process using cross-validation score, which automates the splitting, training and evaluation steps. So for that, let's say like simple cross-validation. And now what I'm going to do is I will say from scikit-learn model selection import cross-validation score. And I will say scores are going to be cross-validation score. I will pass logistic regression at the first place, x, y, and cross-validation of 5 CV. This CV number is the number of folds again, and I will say scores. And here is our scores. Now I will say numpy mean scores, and we can see that we have 0.74 in scores. This method is less prone to errors and much more convenient for quick validation. Okay, let's summarize what we did in this video. We firstly talked about the logic of the cross-validation, then we created a classification dataset, we checked its shapes, then we imported train test split, and I showed you how we can use train test split like this. It's the simple method that we can use. We also import logistic regression and accuracy score for model training. We initialize the logistic regression in here, we trained it, and we check our accuracy. Then we talked about the logic behind the K-fold cross-validation and error calculation. Then what we did is we imported K-fold from model selection of scikit-learn. Then we set the fold number as 5, so each fold are going to have like 200 data points. Then we write a for loop for the cross-validation, we get the accuracies, and we find the mean accuracy. Then we imported stratified K-fold. We talked about its logic, like how it saves the model percentages on every number of splits, like every fold. And then we did the same operation as the for loop. We checked the mean accuracy. Then I showed you how we can imply cross-validation quickly using cross-validation score from model selection. Thanks for watching this machine learning tutorial. I have a playlist named Machine Learning Tutorials where I have more than 40 videos on there, just like this one. You can check that playlist for more videos like this. Also, I'm sharing a new data science video every week on my channel. You can subscribe to my channel for more videos. Have a great day.